So all 4 of the branches in this example are mutually exclusive. It's an if, else chain. It is possible, though, and sometimes very useful, to create a chain of not mutually exclusive branches. In this example, only the 3rd and 4th branches are mutually exclusive. It could be that you could satisfy the first condition, and you could satisfy the second condition, and you could satisfy the third condition, in which case you would go down the first branch, then you would go down the second branch, then you would go down the third branch. Or perhaps you satisfy the first condition and the second condition, but you don't satisfy the third condition. In this case, you go down the first branch and the second branch, and then the fourth branch. The reason for this is that the else will only bind to the nearest if. So even though there's an else here, that doesn't necessarily create a mutually exclusive chain of everything. It's only that the expression there with Boolean expression 3, that's the mutually exclusive with the else. So it is possible, and sometimes quite useful, as I said, to create a chain of not mutually exclusive branches. Let's take a look at a different kind of conditional, which you have not seen before in Scratch. There's something called the switch statement. The switch statement is kind of neat because it's a conditional statement that allows you to specify distinct cases instead of relying on Boolean expressions to make decisions for you. So for example, let's say that I have this program and I'm asking the user to provide input to me. So I say int x equals getInt, and if you're not familiar yet, getInt is a function that is also included in the CS50 library. So if you pound include cs50.h, you'll have access to getInt and all of its cousins, getFloat, getString, and so on. Basically one get function for every data type that we've already discussed. So int x equals getInt. Basically what's happening is I'm at the terminal, I'm asking the user to type in a number. And here I'm switching what I'm doing depending on what the user typed at the prompt. So if they typed 1, I print out 1, and then I break. If they print 2, if they typed 2, I print out 2, and then I break. It's important to break between each case because otherwise you will fall through. So if I didn't have any breaks there and the user typed 1, what would happen is it would print 1, 2, 3, sorry. That's kind of strange behavior, right? You might think so, but there are actually some cases where this could be a pretty useful thing. So here's another example of a switch statement where I omit the breaks, but I do it on purpose. So what happens here? Think for a second. You might even want to pause the video. What happens here if the user types 4? So I've asked the user for input, and they provide the value 4. What gets printed when I do that? On the previous slide, there were breaks between all of the cases, and so it would just print 4 and then stop. But in this case, it won't. What will happen is you will fall through each case. So in this case, I've organized my cases in such a way that if the user types 4, I will print 4, 3, 2, 1, blast off. And if they typed 5, I would start at 5 and do the same thing. If they typed 1, I would just do 1, blast off. So in this case, I'm using a switch kind of cleverly so that I do intend to fall through all the cases. But generally, you're probably going to want to break between all of them unless you have a situation like this one where you're kind of leveraging the fact that you'll fall through the cases without a break. So that's the second of the major types of conditional statements, the last of which is question mark colon. So I have two snippets of C code here, one on the left and one on the right. The one on the left should probably be pretty familiar to you. I have int x, and I probably should have, ask the user for, it should probably be int x equals getInt or something like that. And then I'm making a decision. If some Boolean expression is true, assign x the value 5. Otherwise, assign x the value 6. That on the left should probably be pretty familiar from our discussion of if else just a moment ago. Would you be surprised to know that the line on the right does the exact same thing? So this is called question mark colon, or sometimes called the ternary operator. And it's pretty cool. It's usually used as a cute trick. But what it allows you to do is to simulate an if-else with really small, really trivially short conditional branches. You generally wouldn't use question mark colon if you had 6 lines of code between each set of curly braces. But if you're just making a quick decision, if you're going to do one thing or the other, and it's very simple, this might be an example of how to do it with question mark colon, the ternary operator. So int x equals expression, question mark. The thing after the question mark is what x's value will be if expression is true. The thing after the colon is what x's value would be if the expression was false. So I'm asking myself, is the expression true? If it is, assign x the value 5. If it's not, assign x the value 6. Again, like I said, this is usually just a cute trick, and sometimes if you become really comfortable with it, you'll do this because it looks kind of cool in your programs. Generally, I'm presenting it to you now so that you're familiar with it if you see it. But certainly, no, you don't have to write it in any of your code, but it is something to be familiar with because you'll definitely encounter snippets of code here and there where this question mark colon syntax, aka the ternary operator, is used. So a quick summary on what conditionals are and what the options are available to you in C. You have if and if else and if else if, etc. You can use Boolean expressions for those to make decisions. With switch statements, you use discrete cases to make decisions. You explicitly say, if it's 1 or if it's 2 or if it's 3, I'll do this thing or this thing or this thing. And question mark colon can be used to replace very simple if-else branches or if-else chains to make your code look a little fancy. I'm Doug Lloyd, and this is CS50.
Che calor, Tilo.
All right, so let's talk about loops. So loops are kind of cool because they allow your program to execute lines of code over and over and over, repeatedly, without having to copy and paste or otherwise repeat them. There are three major kinds of loops in C, and you'll probably have occasion to use each one as you progress to CS50. Some of these loops are pretty familiar to you from scratch, so again, as we did with conditionals, we'll put them up side by side if there is an analogy that we can draw. First is forever from scratch, which compares to while true. This is what we call an infinite loop. The lines of code between the curly braces, much like the puzzle pieces that fit inside the C of the forever block, will execute repeatedly from top to bottom over and over and over forever. After all, if you recall from our discussion of Boolean expressions, true is always true. So if we're doing something so long as true is true, it seems a little silly, true is always true, so it'll always run. It'll run forever and ever and ever until we find a way to break out of it with a break statement, which again we saw a little while ago when we were talking about switch. Or otherwise just kill our program, which incidentally, if you ever find yourself in a situation with an infinite loop and you don't know how to stop your program from running, just hit Control and C, and that'll kill your program for you. But this, again, is called an infinite loop. It is a loop that will run forever. Now, while loops are not always infinite, we can also replace the Boolean expression with something a little more useful than just true. So here's another example. While, and then some Boolean expression, and then curly braces. That's pretty much analogous to repeat until from scratch, although in a second I'll explain the difference. So in C, if the Boolean expression inside of the while loop evaluates to true, the lines of code between the curly braces will execute repeatedly over and over and over until Boolean expression evaluates to false. So for example, you might have some sort of counter. So say you at the beginning of this loop, you say int x equals 0. While x is less than 100, do a couple things inside that curly braces. Then at the end of your loop, you say x plus plus. You're incrementing x. So eventually, x will get to 100, and you will stop because the condition x is less than 100 will no longer be true as soon as x is equal to 100, because 100 is not less than 100. Now, somewhat confusingly, the behavior of the scratch block is reversed, so be really careful if this is your first foray into using loops. Basically, the the repeat until block in scratch will repeat something over and over and over until the expression, the Boolean expression in the hexagon, is true. So it will keep doing it until it is true. Meanwhile, the while loop will continue to do it until it is false. So they're quite similar, but there's that little distinction just to be careful of, especially as you make your first foray from transitioning to scratch into C. The next kind of loop is actually pretty similar. It's called a do-while loop. This loop will execute all of the lines of code between the curly braces once, and then it will check the Boolean expression. If the Boolean expression evaluates to true, it'll go back, and it'll repeat that process over and over and over until the Boolean expression evaluates to false. So this loop, unlike a while loop, is guaranteed to run at least one time. This can be pretty useful. Lastly, we have a for loop. For loops are kind of syntactically unattractive, and there's a lot going on here, so bear with me as we try and break these pieces apart. Generally, the use case of a for loop is you want to repeat something a specific number of times. In this example here, I have the repeat block from scratch, which is analogous to the for loop in C, repeating something 10 times. And the for loop on the left there, which is a for loop that would do the same thing. This would go 10 times. We're counting from 0, we increment I each pass through the loop, and we keep doing that until I is less than 10. So what happens? There's a whole lot of code there. Let's break it down into what is happening step by step as we dig through a for loop. The first thing that happened is the counter variable is set, or everything to the left of that first semicolon inside the parentheses is executed. In this case, we are saying int I equals 0. We're declaring a new variable called I. That variable is of type integer, and we're saying the value inside that variable is going to be 0. The second thing we do is we then immediately evaluate the Boolean expression. The Boolean expression is in the middle of the two semicolons. I is less than 10. That's true here, right? We just set I is equal to 0, and so 0 is less than 10, and so that condition is true, and we will now proceed to execute the body of the loop. If it was false, if, for example, I had said, instead of I equals 0 there, I had said I equals 15, int I equals 15, well, 15 is not less than 10, so we would never enter the body of the loop, because the Boolean expression there would evaluate to be false. After we go through from top to bottom and we encounter that closing curly brace, a third thing happens. the counter variable is incremented, or rather, the lines of code or the statements after the second semicolon inside of the for loop's parentheses is executed. So we start out by saying int I equals 0. Then we check whether or not the Boolean expression is true. 0 is less than 10, so it's true. So we're going to proceed into the body of the loop. Things will happen inside the loop, and when we encounter that closing curly brace, the next thing we do is we say I plus plus. So I was 0, now I is 1. Then we again check the value of the Boolean expression in the middle. 1 is less than 10. So we'll go through this process again and again. We'll finish the closing, we'll get to the closing curly brace again. We'll increment I from 1 to 2, then from 2 to 3, and so on and so on and so on until eventually I's value becomes 10. Is 10 less than 10? No. Counting from 0, we've gone through 10 iterations of the loop. We've repeated 10 times, just as we did in the scratch block. And so that's basically the process for a for loop. Now, taking away the actual code and putting it in some sample, just some basic general statements, here's what happens. All of the statements in start are executed first. You might have more than one. Then the Boolean expression is checked. If the expression evaluates to true, execute the body of the loop one time. If the expression evaluates to false, we're done. We don't execute the body of the loop at all. After we've executed the body of the loop one time, we then do what is in the increment part there, which is usually going to be something like I++ or something like that that modifies a counter variable. Then, after we increment, we check the expression again, and we repeat those steps over and over and over until the expression is no longer true. So what are the use cases for a loop? You use a while loop when you want a loop to repeat an unknown number of times, but it possibly might not run at all. A really common example of a while loop being used is to run the control flow for a game. You might not know how long the user is going to be playing, but you want to keep doing the same thing, updating the positions of various sprites on the board. You want to keep things moving at all times, but you don't know when the user is going to stop playing or when they're going to run out of lives. So a while loop is really good for something like that. That's a good use case. For a do while loop, it's pretty similar. You want a loop to repeat an unknown number of times, but at least once. You might use this for a game too, but a really common use case is prompting the user for input. Generally, you might say something like, give me a positive integer. And you might put that inside of a do while loop. So it'll always ask them at least once for a positive integer. If they give you a positive integer, you might break out of the loop. You might be done. The Boolean expression in the do while might be false, and you won't ask them again. If they give you a negative number, though, or they type some word or something that's not really useful to you, you might use the do while loop to go back and do it again and again and again. You definitely want to ask them to give you a number once, but you don't know how many times after that they might be pests. And so a do while loop is a great use case for prompting the user for input. And a for loop's use case typically is when you want to repeat a loop a discrete number of times, though you might not know the number of times at the moment the program is compiled. So for example, maybe you have a program where you prompt the user for a number, say, and they enter 100. And maybe your for loop will then in that case run 100 times. Or maybe they enter 1,000, and your program would then run the loop 1,000 times. It's a specific number of times, but you don't necessarily know what that number is the moment the program is compiled. It's not like a while loop where it could be infinite. It's rather a number that you just don't know. Now, even though I've outlined all these use cases, you should know that in pretty much every circumstance, you can interchange all three of these loops. You can use a for loop where you would otherwise use a while loop. You can use a for loop wherever you would use a do while loop, and so on. It can be a little tricky sometimes, so generally it's good practice to adhere to a typical use case. Use a do while loop if you want to do something once, at least. Use a for loop if you want to do something a specific number of times. After all, that's why there are 3 different kinds of loops, so that they can be used in the right context. But you can interchange them if you want. If you feel comfortable with while loops and you always want to use while loops, it is something that you can do, although it might be a little syntactically tricky, where a for loop would be a lot more straightforward. My name is Doug Lloyd, and this is CS50. Okay, so let's talk about how to use the Linux command line. Now, the CS50 IDE, or in fact even the CS50 appliance, if you're familiar with that, or you're taking an older version of CS50, is a cloud-based machine which runs Ubuntu, which is one of the many flavors of the Linux operating system. Linux operating system is favored by programmers because it's just cooler, right? Many modern Linux distributions have graphical user interfaces, which we also call GUIs, G-U-I, to allow easy mouse-based navigation, which you're probably familiar with if you're a Windows or Mac user, moving around your mouse, double-clicking on icons, and so on. Still, though, as a programmer, and even though the IDE contains the ability to do some graphical user stuff, clicking and dragging and all that, you'll still be using your terminal window pretty frequently. And you can do many of the same tasks that you can do with a mouse with keyboard commands. And we're going to talk a little bit about what some of those commands are right now. Now, these commands can be used on any Unix-based operating system, which includes Linux, but also includes Mac OS. If you open up Terminal on your Mac, you can do this. You can use these exact commands. Windows also has command prompt, but some of the commands are slightly different, so it doesn't actually work because Windows is not a Unix-based system. So let's take a look at some of these Linux commands. The first one that you'll probably use quite a lot is ls. That's a lowercase l followed by a lowercase s, which is short for list. Now what the list command does is it gives you a readout of all of the files and folders in your current directory, so you can see everything you can get to from where you currently are. So I've opened up here the CS50 IDE, and I'm going to zoom in a second to give you a closer look, but here's the broad picture of what the IDE looks like. On the left, you can see we have a file tree, which you're probably familiar with, double-clicking and files and folders and all that stuff. So that's still there on the CS50 appliance. At the center and the top is where you're going to be writing your code once you click on a file. And at the bottom, we have a terminal window, which is where we can execute these terminal commands. I'm going to zoom in and head over here just to show you that, in fact, I do have, I can click on these files and folders. So clearly, where I currently am, I have two folders called pset0 and pset1, and three files, one called hello, one called hello.c, and one called hello.txt. So let's move down to the terminal window and get a closer look. So we just talked again about the fact that we have three files and two folders in the current directory. If I type ls, which again is the command to list the contents of the current directory, and then I hit enter, look what I see. Hello, hello.c, hello.txt, pset0, and pset1. pset0 and pset1 are colored blue to indicate to you that those are directories that we could navigate into, and we'll learn a little bit about how to navigate into directories in a minute. And every other thing is colored black if it's a text file or a source code file, and green if it's an executable file. So clearly that means that I could run a program called hello. That's what the green one there means. But basically typing the ls command has allowed me to look at everything that exists in my current directory, which matches what we see here in the graphical display the same. The next command you probably use quite a bit is cd, lowercase c, lowercase d, which is short for change directory. This allows us to do what I was just talking about a second ago, which is to navigate between directories at the command line as opposed to double-clicking on folders. So if we type cd and then the name of a directory, we can get into that directory. As an aside, know that the name of the current directory is always dot, and the name of the directory one level above where we are now, that is the name of the folder in which our folder is dot dot, or in which our folder is dot dot. And if you're ever curious about the name of your directory, you can type pwd, which stands for present working directory. We'll take a look at all of these now by heading back to the CS50 IDE. So I'm back in my workspace now, and I'll zoom in again on the terminal so we can take a look at moving around within the IDE. So I'm going to list the contents of my directory again just to reground us in where we are. So if I type ls, which is for list again, I see that I can get to pset0 and pset1. Those are the directories I can get to from here. I know that because the IDE gives me a clue by coloring them blue. Let's say that I want to get into my pset1 directory, because I'm working on problem set 1. I can type cd, again, short for change directory, space pset1, and if I hit enter, notice what happens. It doesn't look like a lot has happened, but if you look at the prompt, it now tells me that I'm in ~workspace/pset1. I've navigated into the pset1 folder that was within my workspace. And if I type ls, I see some different stuff here, right? This isn't the same list that I saw before. I've navigated into pset1, and so now when I type ls, I'm getting the context of what can I see from within the pset1 folder. Now I'm going to type Control-L, which just clears the screen, and I'm going to list the contents of the directory again just so you can see. I just wanted to do that to clear out some of the stuff that you saw down below and to prevent this from going too far down out of range. Now I said earlier that if I want to navigate to the current directory, I can type cd space dot and hit enter. It doesn't do anything, right? I'm changing directories to the current directory. You're not always going to find a need for single dot, but you will occasionally. Let's say that I want to move up one level. I want to get back to my workspace directory. I can't type cd workspace. There's no such file or directory. And the reason for that, if I type ls one more time, is that there's no directory called workspace inside of my pset1 directory. I'm going to clear my screen again with Control-L. Remember what I said earlier, though, that we can navigate back with dot dot. That's the name of the parent directory. So if I type cd space dot dot and then hit enter, now look at what happened. My command prompt tells me that I'm back in my ~workspace directory. I moved up one level thanks to dot dot. Now, let's say that I'm using an operating system that is Linux-based but doesn't necessarily tell me where I am. This one happens to tell us that I'm in ~workspace right now, right at the prompt. But I could be completely lost in a mess of folders, and I have no idea where I am and no idea where I want to get back to. There's two things I can do. First of all, I can figure out where I am by typing pwd. That's my present working directory. And if I hit enter, it tells me exactly where I am. Now, /home/Ubuntu is the long way of saying tilde, which is your home directory. But it tells me that I'm in home Ubuntu workspace or ~workspace. I'm going to navigate to my pset1 directory again. And I'm going to list the contents. And I see that I have another directory there called extras. So I'm going to cd into extras, and then I'm going to clear my screen. So now I'm pretty far in, right? Like I have what if I want to get back to workspace immediately? There's a couple things I could do. I could type cd dot dot slash dot dot to move up one level and then another level, but that's kind of annoying. So if I ever want to get back to just my home directory, tilde, I can type cd with nothing after it. Cd enter, and now I'm in tilde. And then if I want to get to workspace, I can just type cd workspace. And that's how you work changing directories within the CS50 IDE or any Linux operating system at the command line. All right, the next one that might come in handy is mkdir, which is short for make a directory. If I need to create a new folder. If you're familiar with a GUI operating system, you might right-click, and then when the context menu pops up, choose new folder. That's probably how you've done it. Pretty far in, right? Like I have what if I want to get back to workspace immediately? There's a couple things I could do. I could type cd dot dot slash dot dot to move up one level and then another level, but that's kind of annoying. So if I ever want to get back to just my home directory, tilde, I can type cd with nothing after it. Cd enter, and now I'm in tilde. And then if I want to get to workspace, I can just type cd workspace. And that's how you work changing directories within the CS50 IDE or any dir, which is short for make a directory. If I need to create a new folder. If you're familiar with a GUI operating system, you might right-click, and then when the context menu pops up, choose new folder. That's probably how you've done it before. But we can also create directories at the command line. So we're back in the IDE. I'll zoom in on the terminal. And list the contents of my directory again, just to get us back, just to give us a frame of reference. Let's say that now I finished working on problem set 0 and problem set 1, so I want to create a new directory to work on for problem set 2. How do I do that? Well, again, I could right-click on the left side there and choose new folder and create a pset2 directory. That would work too. But I can also do it at the command line pretty quickly by typing mkdir space, I typed an N, but space, pset2. If I hit enter, and then I list the contents of my directory again, I see that, look, now I have a pset2 folder, and I can navigate into that using cd and do all the work I need to do for pset2. Incidentally, I'll just pop over here really quickly to the file tree, and you can see that also in the graphical file explorer, we can see that the pset2 directory has also been created there, and I can navigate to it using the GUI as well. The next command that's probably going to come in handy is cp, which is short for copy. Copy, unlike all the other commands we've seen before, takes two arguments: a source, the name of the file that you want to copy, and a destination, where you want to copy the file to. It's pretty easy to copy a file, so let's do that. So we're back in the IDE. I'm going to list the contents of my current directory with ls. Now, let's say that I want to make a copy of hello.txt. Again, from the file tree on the left, the graphical interface, I could right-click on hello.txt, make a copy, paste the copy, but I can do it pretty quickly at the command line, too. Let's say I want to copy hello.txt to hi.txt. I can cp space hello.txt. That's my source file, so that's why I'm going to choose that one first. And then I need to name the destination file, hi.txt. I hit enter, and if I list the contents of my directory again, there's hi.txt. I made a copy of it. And in fact, if I went into hi.txt, I could see that it would be an exact duplicate of everything that existed in my hello.txt file. So that's how you copy a file. But what if you want to copy an entire directory? So for a second, let's take a look at what's in my pset0 directory. If I cd pset0 and list the contents, I have a directory called sample and a scratch file, scratch.sb2. So that's good to know. So let's clear the screen, and I'm going to go back to my workspace directory for a second. Let's say that now I want to make a copy of my pset0 directory. I can't just say cp pset0 pset3, for instance. You get this weird message, omitting directory pset0. Why do you get that message? Well, it turns out that when you have a directory that has other stuff inside of it, the cp command doesn't really necessarily know what to do with it. We need to explicitly tell Linux, the terminal, I want you to copy the pset0 directory and copy every folder that exists inside of it and every file that exists inside of it. In other words, I need you to recursively dive down into pset0 and make a copy of everything in there. If I want to do that, what I can do is cp-r for recursive, pset0, pset3, hit enter. Now, if I list the contents of my directory, I see there's the pset3 directory that I can work with. And if I cd into pset3 now, and then list the contents, look, there's sample and scratch.sb2 again. So that's pretty cool. So that's how you can copy an entire directory and not just a single file. So if you want to copy a directory, just remember to use the -r flag when you're working with the cp command. All right, so I've copied a file, but I've done it by mistake. Directory, just remember to use the -r flag when you're working with the cp command. All right, so I've copied a file, but I've done it by mistake. But at the command line, we can just type rm for remove, and then the name of the file we want to get rid of. Now, rm is very careful. It makes sure that it does a lot of double checking to make sure that you actually want to delete the file. It doesn't want to make any mistakes because there's no recycle bin here. Once we delete a file, it's gone, and there's really no way to recover it. So we need to be pretty careful, and so rm is going to be really careful for us. So let's go back to the IDE and get rid of that hi.txt file that I created a minute ago with copy. So we're in the IDE, and I'm going to list the contents of my directory again just to give us some context, and we can see that there's hi.txt, which I created a little while ago. Now I want to get rid of it. How do I do it? Again, just rm. So I can type rm hi.txt and hit enter. And there's rm being really careful for us and making sure we actually want to delete this file. Do you really want to remove regular empty file hi.txt? That's just like an operating system like Windows or Mac that you might be familiar with, popping up that box that says, are you really sure you want to do this? I'm pretty sure I want to do this. So I'm going to type yes, or I could also just type y and hit enter. And if I list the contents of my directory again, hi.txt is gone. Not bad, right? Let's press Control-L just to get rid of all this stuff and get us back at the top of the screen. Now, there is a way to short-circuit rm so that it doesn't ask us that question. We really know we want to get rid of that file, and we don't even want to be asked the question. How do we do that? Well, we can specify an extra flag, just like we did with cp, where we could add the -r flag to recursively copy into a directory. There's another flag for rm, which is -f, which is to force rm to do exactly what we're telling it to do. So let's say that now I want to get rid of my hello.txt file. I don't want that one either. What can I do? Well, I can rm-f hello.txt. What do you think is going to happen here? It's gone. Didn't even ask me the question. And in fact, if I list the contents of my directory again, it's gone. There's no undo here. Hello.txt is gone, and I wasn't even asked if I wanted to delete it. What if I want to get rid of an entire directory? The way you do that is very similar to copy. You need to, if you want to delete a directory, you don't just want to delete the directory, you want to delete everything inside of it. And so you use -r to recursively delete a directory. So let's rm-r pset2. I'm not actually working on pset2, so I can get rid of that directory. I hit enter. Do I want to remove the directory pset2? Yes, I do. And if I list the contents of my directory again, it's gone. All right? One more variation on this theme. So I'll clear the screen again to put everything at the top. Hit ls. Now I want to get rid of my pset3 directory, and I really know I want to get rid of my pset3 directory. I can recursively and forcibly remove my pset3 directory. Now, you got to be really careful when you're using rm-rf. As you program more, it'll be something you just do really quickly. And in fact, I do it all the time, but it can lead to some disastrous consequences if you accidentally delete the wrong thing. So I want you to be aware that this is an option available to you, but use it sparingly and use it with caution. I know for a fact I'm not working on my problem set 3 anymore, so I'm going to get rid of all of those files. And I know I don't want to be asked every single time if I want to delete a file. So I'm going to rm-rf pset3. Didn't even ask me if I wanted to get rid of it. I hit ls. pset3 is gone. So that's all the variations that you can use to get rid of files with rm. The last command line argument that's probably the command line command that's going to be pretty useful for you is mv, which is short for move. Move is basically equivalent to rename. It moves a file from one location to another, the source to the destination. Let's see where using a move might be handy at the terminal window. So I'm in my pset1 directory, and I've noticed something has gone a little wrong. I was working on my greedy problem, but I accidentally named it Greddy. So when I try and run it through check50, it doesn't really work. I do have a couple of options. We could do what we've done before, which is to make a copy of the file. I could copy Greddy.c to greedy.c, right? Hit enter. I see that both files are there. And then I could rm to remove Greddy.c. That gets rid of it. So that would work after I confirm that I want to get rid of it. And I effectively have renamed Greddy.c to greedy.c. I copied it and then removed the original. But that's a multi-step process, and certainly there's a better way. In fact, there is. So let's hit Control-L just to bring this back up.
New studies available on Prolific.
My directory again. So let's say, oh, I made a mistake. I actually really did want to call that file Greddy.c. In one fell swoop, I can type move greedy.c to Greddy.c. Hit enter. And now I didn't have to copy and remove it. I just was able to rename it. One-stop shopping. Now, there are a lot of other basic command line utilities that you can use at the Linux command line, and we'll be discussing a lot of them in the future in CS50. But for now, just getting your feet wet with working with this terminal environment, these 5 commands should get you pretty far in navigating around and working with files in your IDE or in whatever Linux-based operating system you're using. If you're curious and you want to look ahead a little bit at some of the command line commands we'll be using in the future, here's a list of a couple of the more common ones. I'm Doug Lloyd. This is CS50.
Dus test. Oh shit. Sorry. Didn't.
It's not necessarily a good thing that you sneak it by, though. I'm Doug Lloyd, and this is CS50.